All right, we're going to talk about factoring some more. And this different method here is called factoring out the difference of two squares. It's going to be different than this idea of factoring out a greatest common factor because it's not going to set up the same way. This kind of looks like this. This is not the difference of two squares. There is a difference, and that is a perfect square, but 15 is not a perfect square. So I couldn't use the difference of two squares here. In order to develop it, though, let me go this way. And I usually don't develop on these videos, but I'm going to this time. If I were to do the math on this, let me multiply these two things out. And I know we know how to multiply. So let me just go ahead and write that's a squared minus ab plus ab minus b squared. That's just by using distribution. Now, if I look at this, I can combine these two. So a squared, what is negative ab plus ab? Well, they're gone. And now I still just have, so since they're gone, just minus b squared. So when I start off with this, I end up with that. So from that, I'm going to say that this a squared minus b squared, this thing I came up with, it's the same as the thing I started with. I just kind of rewrote it by using the distributive property. So a plus b times a minus b. So when I see that I have the difference of two perfect squares, I can write it like this. Take whatever that is and write it here. Take whatever that is and write it here. Do it again. Make 1 plus, 1 minus. Again, the theory is a little tougher to see than the actual example. This is a binomial. There is the difference. This is a perfect square because x times x is x squared. And this is a perfect square because 5 times 5 is 25. Well, the moment I recognize it's a difference of two squares, I can factor them, write them out as factors, things multiplied together, by just saying whatever this thing is, x, write it here and here, and whatever this thing is, the square root of 25, which is 5, write it here and here, make one positive and one negative. One's positive, one's negative, and I'm done. If you were to multiply that out, you'll see you'll get this. Let me do a different example. What if I said something like 36x squared minus 49y squared? Well, the question really is this a perfect square? 36 is a perfect square because 6 times 6. X squared is a perfect square. That's x times x. So yes, that's a perfect square. What about this one? 49? Yes, it's a perfect square. Y squared? Yes, it's a perfect square. By the way, the square root of 49 is 7. So yes, this is a perfect square. And do I have the difference? I do. So I found that this is the difference of two squares, and I see that and get excited. I just need to take the square root of this thing. That's going to be 6x, and I write it in both places. Do the same thing here. That's going to be 7y. Write it in both places. Since it's the difference of two squares, one's going to be plus, one's going to be minus. It doesn't matter which one you do because they're the exact same thing. All right, so difference of two squares. Let me do another example. Maybe you might have to do something like this. So what about like 48 a to the third minus 12a? Now, if I look at this, this is not a perfect square. So I could be like, okay, that's done. Well, this is not a perfect square either. But notice that I see that, I see that 48 and 12 are multiples of each other. So what if I pulled out a greatest common factor first? I can pull a 12 out of both, and I can pull an a out of both. Let's see what's left. Well, 48 divided by 12 is 4. If I had 3 a's and I pulled out 1, I still have 2. 12 divided by 12 is just 1. And if I had 1 a and I pulled out an a, I don't have any left. So wait a minute. After pulling out the greatest common factor, I see that this is actually difference of two squares. That's a perfect square. That's a perfect square. So in order for me to actually factor this out, let me keep my greatest common factor. But now, since I have the difference of two squares, I can just write it. The square root of 4a squared is just 2a. Write that in two places. The square root of 1 is just 1. And since it's the difference of two squares, one's plus, one's minus. Altogether, this is the factored form of this binomial. Difference of two squares.